All right, everyone, it's Mr. Who. Haven't seen you in quite a bit, but I'm back with some more pre-calculus for you. So today we're talking about function compositions to kind of piggyback off of function operations. Okay, this is kind of a step up from that, but basically a function composition is taking a function of another function. Okay, taking a function, okay, of another function. Running out of space there. Another function. Sorry for my little chicken scratch. If you want like a typed version of it, look at the guided notes. Okay. And we're going to learn about two different notations. Okay. You've probably seen this before in Algebra 2. Okay. But there are two notations to really look at. There's this idea of an f, okay, containing another function as the input, okay, with the double sets of parentheses. And then there's also this idea of f of g, okay, in parentheses itself, of x. Okay. So those are the two notations you'll most commonly see. And you read that f of g of x, regardless of whichever notation you use. This one's a little easier to see. F of with a little symbol, g of x, right? So those are my two notations I'm going to talk about using, okay, in function compositions. Now, when we talk about function compositions, there's going to be two main types, okay? There's going to be a type with variable, okay, whereas there's no given value, and then there's one without variable, so it actually asks you to get a value, okay? And I'll show you a couple examples on Delta Math as well, but I'm going to do it with an example here written for you in the first place. So let's pick a couple easy ones, okay? Let's say f of x is something like 2x plus 4. Okay. Very simple linear equation, linear function. Okay, let's make g of x a little harder. I'm going to say x squared minus 6x plus 3, something like that. Okay, so those are my functions here. And let's say I want to find, okay, f of g of x. Okay, well, if I want to find f of g of x, here's my procedure. I take a look at what's inside, okay, what's the inner one, the inner function. It's my g, so I'll go ahead and start writing that out first. It's my x squared minus 6x plus 3, okay? And once I've written that, it only serves as a substitute for my x in the f, in the function f of x. So this would be my, I'll use a different color here, okay? This replaces my x in 2x plus 4. Okay, so that is how compositions work. Now to simplify it, obviously, you would just take the number out here and distribute, okay, to get your nice and simplified form. 2 times x squared is 2x squared minus 2 times 6, which is 12x, plus 2 times 3, which is 6, plus 4 on the outside, okay, which combine those into 10. I'll go ahead and erase them and put them as 10. Okay, to save myself a little bit of space because I'm kind of running out. Okay, and this would be the function f of g of x. Okay, this thing right here. I'll use a kind of a green box to indicate that that's my answer there. There you go. Okay. So really all I did was plug in one function right into the other function as my value of x. You don't have to know the value of x is, okay, in this scenario with variable. You just kind of plug one piece into the other, whichever one's inside goes in first. The outside kind of is consuming the inner one. You can think of that way. Okay. But now let's ask a different question. Okay. The other question you guys have to answer, okay, with regards to function composition is finding a specific value, okay, with an input, a given input. So let's say I want to find g of f of 3. G of f of 3. Okay. So with this problem, I know what my x is. So there are a couple of ways to do this. I'm going to do a little split here. Okay. Do a little split here where here is I plug in 3 to f first because f is on the inside. Okay. So that's 2 times 3 plus 4. That's my f of 3. And then I take the result from this, which is 2 times 3 is 6, plus 4 is 10. So that is 10, of course. And then I take that and plug it into g. So now I'm looking at g of 10 equals, well, it's going to be 10 squared minus 6 times 10 plus 3, which is 100 minus 60, 40 plus 3. That's 43. So that's my, I'll use a red this time, okay, to kind of say this is my value, okay, when I take g of f of 3. Okay, I put 3 into the whole thing, I should get 43 out once I run it through two functions. Okay. All right. Now for the other side, the other way to do this, okay, is to actually find the variable version so you can just do this variable step. Okay. Or I can say, okay, I need g of f of x. So I'm going to put my f of x first, 2x plus 4. Okay. And I'm going to just insert it wherever I see x and g of x. So that would be squared minus 6 times 2x plus 4 plus 3. And then I solve that out and do it that way. Now, of course, this way might be a little longer depending on what you're looking at here. But if I had asked for f of g of 3, okay, just as an example, you could technically use this form and plug 3 right into that, okay? Because this is the composition that happens to any x you put in. This is what happens when you put in a specific value, specific input for x, okay? So I'm not going to do the rest of this out because I kind of don't want to foil all of this, okay? Just know that you get a general form, okay? You get that g of f of x, and then you plug in 3, okay, after simplifying, okay? Which may or may not be that bad depending on your problem, but this one is particularly bad, so I will not be doing that. Okay? This is pretty easy to do. Okay, plug it into one function, get your number. Plug it into another function, get the final answer. Okay, so let's go over to Delta Math and take a look at a couple of the modules for this lesson. All right, so I'm here with Delta Math. I'm over here now in the top left instead of the right over there, so I can have more room to write. But here's an example problem. This is the module composition of functions with a value, a given value, a defined input. So again, there are two ways, like I said before, and here are my two functions that they're given to me. So I will be doing the first way I showed in the notes prior here, and then I'll show the second way over here on the right once I get there. Okay, so there are two ways to do this. I'm going to show both of them so you have a kind of an idea of how these problems kind of work. So the first way, like I said, was to plug in 0 to whatever function's inside. So in this case, it'd be f of 0. Let's go ahead and find f of 0. If I set x equals 0 in that first one, it should be negative 0 plus 9, which, well, negative 0 doesn't really have a value still, and that's going to be 9. Then I take the answer here, and I plug it into my g of 9, equals 9 squared minus 6 times 9 plus 9. That's a lot of 9s, okay? But keep a level head. 9 squared is 81, minus 6 times 9, which is 54, plus 9. Okay. In the end, I think this is going to end up being something like 36, if I'm not mistaken. So I'll use a green circle for that one. So far, I think, okay, 36 is probably what I'm going to end up putting in the box, assuming I did all my math right. Okay. But maybe you want a different way. Maybe you want a way to check your work. Okay. Here's the other way. I'm just talking about g of f of x. I'm not talking about any zeros right now. I'm just going to put my f of x, negative x plus 9. Okay. And I'm going to plug it straight into my g of x. So that's going to be x squared minus 6 times x here plus another, I'm going to run out of space here, plus another 9. Okay. And then I got to simplify it. Now, this is a little easier to square than the one I did in the notes earlier, so I'm going to go ahead and square it. It's going to be x squared minus 18x plus 81. That's what that one is. You can do the math on your own if you don't believe me. Minus 6 times minus x is plus 6x. Minus 6 times plus 9 is minus 54. And finally, I have that plus 9 chilling on the outside still. So I just combine all my like terms. I only have 1x squared after all. Minus 18 plus 6 minus 12x in total. And then the plus 81 minus 54 plus 9 actually works out to be that 36 from down here. So we're kind of have an idea of where this is going. Okay, this is my g of f of x. And what I'm trying to find is 0. So I plug in 0 for x. Okay. 0 squared minus 12 times 0 plus 36. Well, 0 times anything is 0. So those all cancel out, and I'm left with 36. And lo and behold, that is the same thing I got over on the left. Okay. So two ways to do it. Okay. I would say there's a bit of foiling over here that's necessary, some simplifying. Okay. Shouldn't be any factoring. So if you're not confident in your simplifying skills or you think it'll take a little longer, just plug it in and then plug the result you get there into the second one. That's the easiest part. So let's go ahead and check my answer. Make sure I'm not tripping over my words here, but my answer of 36, I got it twice, so I expect it to be correct. And delta math does indeed say it is. Okay. Now, delta math does it the first way, the easier way, quote unquote, where you plug in the f of 0, get your number out. Here's the 9, by the way. And then you plug that 9 into g to get your final answer of 36. Okay. So that's with a value. I'll show you another example without the values, with just the exponents. We'll go through that process one more time before I let you off. All right, so here I am back again. This is going to be the composition of functions with x. Okay, so I don't have a value they want me to evaluate at the function. They don't want an output. They just want the actual composed function. The composed functions. Here are my two functions, and here's what I want to find, my g of f of x. Okay, now remember, this is just another notation where this is g of f, where the second one is the inner one. Okay, you can also rewrite it as g of f of x if you really want to. Okay, I typically prefer that way, but this is also notation you kind of got to know. Okay. So if I know my f of x is first, I'm going to put my negative x minus 6. That's going to be what I put in for everywhere I see x in g. So 3 times this thing squared plus 7 times that, not squared because it's just middle term, and then finally plus 15. Okay. Note that there's only one way to do this. There isn't going to be I plug something in and then I try to get something out. You're just going to be plugging in whatever functions on the inside and then simplifying. So let me actually do the squaring first, because remember PEMDAS, you got to do exponents before you do multiplication. So I'm going to leave that out here for the moment being. Negative x minus 6 squared. That's going to be x squared plus 12x, if I do believe, plus 36. Okay. If you're wondering where that middle term comes from, I implore you to do the foiling. Okay. But it's past the point where I can tell you this is not going to be x squared plus 36. So if you don't know that still, I would say FOIL it out manually without trusting this exponent. Okay. All right. Then I have plus negative 7x, so it's negative 7x here, minus 42, it looks like. Finally, plus a 15 on the outside there. Okay. Then I can distribute my 3. So let's go ahead and distribute my 3. 3x squared out there, 36x, and then 36 times 3, oh, that's 108, I believe. So there we go. Minus 7x, minus 42 plus 15, that's actually 27, if I do say so myself. So quick maths on that one. So combine their like terms to clean it up a little bit. X squareds don't have any extra terms to add. 36 minus 7 is 29. Okay. And 108 minus 27 is actually, let's see if I can do this math right, 81. Okay. It should be something like that. So this would be your final answer. I can get the box out. This would be your final answer. It's a little off, so okay. There is no need to kind of think about, okay, what else do I need to do with it here? Once you've gotten it down to standard form, okay, I made it nice and simple, nice and tidy. That should be the final form of our composed function. In the end, if I want to find the value of x in this composed function set, I can just plug that number directly into this function. Okay, so let me put that in. 3x squared plus 29x plus 81. And submit here. Ta-da! Okay, so take a look at what they have to say about the matter. Okay, they say find g of f of x. F of x is first because it's on the inside, and then you put everything inside. They even have the little format here where it's g of whatever your f is. Okay, so if that helps you remember that too, you can use that as well as kind of figure out what am I supposed to put in for x in the second one, or the one on the outside. They do expand the square for you here. They do say it's this x squared with middle term. So even delta math says it. That must not be crazy then. Okay. And then final answer comes down to the combining and distributing and all that other good stuff. All right. Well, that's pretty much all I got to say about function composition here. If you're wondering what we use it for, okay, we actually use this for quite a bit of things, okay, but mostly when you talk about higher level math. Okay. I will also talk about like maybe a real application. Like you may not think about this, but this is kind of what this is supposed to represent in the real world. Okay. But in the terms of the math world, we use this when talking about higher level maths, when we're moving from sets to sets, okay, functions to functions, stuff like that. All right. Well, I hope you enjoyed this little talk about function composition, maybe a bit of a shorter episode this time. But I will see you all next time with whatever else I have to talk about. So, see you then.